Okay, good morning, everyone. Hope you had a nice party yesterday. Today's keynote speaker is Barbara Weber. She is a professor of software systems, programming and development at the University of St. Gallen in Switzerland. And before, she held positions at the Technical University of Denmark and also a long time at the University of Innsbruck in Austria. She has presented many times at CAiSE', but I think this is the first time as a keynote speaker. The title of the keynote is The Power of Events and Information Systems Engineering Perspective, kind of. Please, you have our attention.
Thank you very much, Gerd, for your attention, and thanks to all of you that you are already here after the conference party yesterday, so that's really great. Gerd already mentioned that I was presenting at CAiSE' many times, so my first CAiSE' was in 2007, where I presented a paper on change pattern. Change will also play quite an important role in today's keynote because events are at the heart of event-driven systems. These are systems that are responding to changes. And events can also play an important role, especially sequence of events, to investigate how certain phenomena evolve over time. So the topic of the keynote is quite broad, and I probably also raised some expectations by borrowing the title, The Power of Events, by quite a famous book on event processing. And it will be quite impossible to cover everything that can be said on that topic. Events are such a core concept that it touches the work of many of you, and there have been also numerous papers at previous CAiSE' editions that in one form or the other relate to events. I will take a specific lens and especially look at events on the one hand from a change perspective, but also from a process perspective. And it's really important for me to mention when I'm using the notion of process, you shouldn't just think about business processes, but about the notion of process in a much more general sense. So since the topic is so broad, I will probably not be able to cover everything, be to some extent incomplete. And I'm also quite aware that you might have another view than the one I'm going to present. So what I hope at least that the keynote will trigger some interesting discussions on the topic afterwards. So apart from conceptualizing events and event sequences, roles of events, I will also illustrate things with a couple of examples from my own research of my team, which might at the first glance appear quite unrelated, but when you look closer, you will see that all of them have to do with event sequences and the analysis of that. So I will start the keynote by briefly talking about what events are before then going into some examples. And very often events are defined as occurrences about something that has happened. And when we then have multiple events, they can be related to each other. They can be related by time, by causality, abstraction, or other relationships. Very often events relate to situations in reality, and if we are able to make observations about them, either using sensors or using an information system, then we can make a record of them. And those records can then result into event sequences, which we can, for example, publish on an event stream, or we can capture them as part of event logs. Since events refer to something that has happened in the past, they're usually seen as something which is immutable, and some people even go so far as calling them immutable facts, which I would say can be debated, because in principle we could also have virtual events, simulated events that are not really referring to things that have happened in the past. Events in our event sequence are typically ordered, and when we think about event sequences, a desirable property is also that we can replay these event sequences. They can come keyed or unkeyed. So for example, we can use keys to group events that are in one way or the other related. So for example, in the context of process mining, we often use the notion of a process ID to group related traces that belong to one instance into traces, and each of those traces would then constitute an event sequence. But we can also use whatever else we would like to use in order to create those groupings. It could be an order ID which groups all events that belong to the same order together and captures them as event sequence. What I did in preparation of CAiSE, of this CAiSE keynote, I looked at the proceedings of the last couple of years. So I started from 2016 until last year. So this year's proceedings were out relatively recently, so they are not yet captured. And I did a search in the proceedings for the notion of event. I excluded all the papers that only captured or talked about events, I would say, as a remote topic. But what remained were 63 papers out of 260 papers accepted for the main conference that in one way or the other had events as one of the core concepts. From those papers, 52 papers focused on event sequences, and you will see in a second that those event sequences also at CAiSE are coming in quite diverse flavors. Of course, not very much surprising, process event logs played quite a big role. Most of them captured traces with events related to the business process execution. Very few examples had unlabeled logs. There was one paper looking at how to augment process event logs using natural language processing, and very few papers that looked at collections of logs, either to compare different logs or to mine entire process families. Then there are a bunch of papers that look at, they called it low-level interactions. That could be location data that was used, for example, for interaction mining. And in that context, the device or the entity to whom the device belonged was used as a key to organize the event sequence. There are examples of mouse clicks and keystrokes used for task mining and preparatory steps for robotic process automation, and also generic low-level events where a process ID was used as the key. Very few papers focused on streams of events, some of them in a generic form, talking about instantaneous and atomic event occurrences. One example which captured process events in a stream, and one example of using multiple streams of data coming from various sensors. There were cyber-physical systems logs describing the behavior of different cyber-physical components, like, for example, drones, where the scope, so that the ID of the physical component was used as an identifier. And finally, I could also find one paper focusing on customer journeys. These are long-running traces of customer interactions. So what you can see that it is already quite diverse what was happening just at this single conference when it comes to event sequences. When looking at the papers a little bit deeper, I made a couple of observations. So what I already pointed out, that process event logs were very well represented. What was interesting to see, despite that we are now faced more and more with cyber-physical systems where data is produced by sensors, that there is still a very limited focus on event streams, especially also on, I would say, the online processing of the respective data. Also interesting to note that most of the works focus on a single event sequence. There are only very few works that already take multiple event sequences and analyze them in relation to each other. Most of the works assume that there is one identifier key available which allows to group related events. What I also found very interesting, that very few papers, only 3 out of the 52, refer to distributed settings. And this is especially surprising since nowadays there are so many connected devices out there that are producing event data. And the minute you are trying to combine these data sources, there are coming a lot of problems up that are originating from this distributed nature. The reason that most works only focus on single events might explain that to some extent. What I also found interesting, that only very few papers refer to data collection infrastructures and how to collect this data from the different devices. So having now illustrated a little bit these many flavors of event sequences, I would now like to step a little bit back and reflect a little bit what different communities are understanding when the term event is used. One of the viewpoints, and I think this is a viewpoint that is familiar to many of you, is the one that the complex event processing community takes. And there are a bunch of notions, which I will explain in a minute, that are typically used in the event processing community in order to distinguish different forms of events. So on the one hand, there are raw events. These are typically event objects that record a real-world event. There's also this notion of an instantaneous event, so an event that happens at a particular point in time. So something which is atomic and doesn't have any duration. There's this notion of a simple event, so an event which is not viewed as summarizing or representing or denoting a set of other events. And in contrast, we have the notion of complex events. Complex events are typically events that are in one way or the other summarizing, and very often when we talk about complex events, we are moving from single time points to intervals that are summarizing something. Closely related to that is the notion of a derived event, which results out of some sort of processing. Either can operate on single events, can operate on complex events, but there is some sort of processing involved. And there is the notion of a composite event, and this is really at the heart of complex event processing, where different either simple or complex events are combined. And usually using some form of event constructors like conjunction sequences. And what is very characteristic for those composite events, that the member events are typically part of that event. And finally, and I think that's interesting for simulation and also prediction purposes, there are virtual events that are events that do not happen in the real world, but are imagined, modeled, or simulated. So all sorts of different notions that play an important role in the event processing community. When we look, however, at other communities, there are different viewpoints and lenses taken. And another one which I find quite relevant is what is happening, especially in the stream processing space. When you look at distributed event processing architectures or platforms like Kafka Stream, then there is a different bunch of terms used that are in one way or the other related, but still there is distinct terminology. So what I describe here is a bunch of notions which are explained in some of the blog posts of Neil Avery related to event first thinking, where events are really the notions that are driving the execution of an event-driven system. And there is, on the one hand, the notion of an atomic event, which is quite similar, I would say, to instantaneous events, simple events that we have seen before, that usually refer to event occurrences, something that has happened. Like, for example, a bit on an item, a device temperature, those could be atomic events. These atomic events, they are usually not looked at in isolation, but we are usually looking at related events. And in that context, for example, have streams of sequences of events that are looking at related events, like, for example, tracking price changes, device metrics that are changing over time. So this is the notion of related events captured in an event stream. And then there is this notion of behavioral, which is defined as the accumulation of facts capturing some sort of behavior. So for example, imagine a user putting an item into a shopping cart and then removing that item again. If this is happening with several users, it could be interesting to investigate what are the conditions that, under which this is happening, and to investigate whether there are some interventions to take care of that. So those are the notions that we typically can find when it comes to more classical stream processing solutions. This terminology is also quite related, I would say, to some of the big technology stacks that are out there. On the one hand, event and stream processing. So I mentioned Kafka streams before. This would fit as an example into that class of systems, where we, on the one hand, can distinguish between event processing. So that would operate on single events, and we don't need to take other events for the processing into consideration, like filtering, branching, translation of one event into another one. So those are typically stateless transformations that don't require memory about other events. And then there is the notion of stream processing, where we look at related events, so events that are part of the same event stream. And what we typically have there are operations like grouping, windowing, aggregations in order to calculate low-level pattern. Like, for example, the number of mouse clicks over a 5-minute window. And those are things these stream processing platforms are very good at. But they are typically limited in detecting what are so-called composite events, which are events that are composed of several different member events and form more complex pattern. And this is where complex event processing comes in. And I think there are two distinguishing features that really distinguish the classical event and stream processing from complex event processing, and these are conceptual hierarchies, so events can form hierarchies, and also the notion of causal relationships. A final perspective I would like to take comes more from domain-driven design microservices, also event-driven microservices. That's also a community where events really play an important role. Events in that context are so-called domain events, and there is also this very well-known notion of integration events. And when I'm talking about the domain events in the context of domain-driven design, then I'm referring to something that has occurred in the business domain and is important to domain experts. And I think this is really fundamental. It is part of the domain model, and it is expressed in an ubiquitous language, so in a language which is really understandable for the domain expert. And I think in contrast to what we have seen before with event processing, where complex event processing, where we try to detect and recognize events, in domain-driven design we are modeling them. It's something which really matters for the domain expert, and is usually something which is starting in the process relatively early. There are techniques like, for example, event storming, where the whole process about conceptualizing the system starts with the notion of events. And those demands usually, domain events usually reside within the boundaries of one particular bounded context or service microservice. The notion of integration events, in turn, is used when one service wants to notify another one about relevant state changes within the domain. Those events are typically only emitted when the transaction related to the emitting service was working successfully. Then the event is emitted and can be, for example, used to communicate side effects. So what I find super interesting, that the notion of events plays a role in different communities. In some cases, it is more about changing abstraction levels of events. In some cases, like in domain-driven design, it's really about emitting something which is relevant from a domain point of perspective. What is also, I would say, quite challenging is to really manage all that terminology and not to get confused, because depending on what community you're looking at, there are all sorts of notions that are used, and I'm very much sure that if we take some additional communities in, there will be more happening. Some of that consolidation efforts, I think, are already happening. For example, Giancarlo and his work on event ontologies, I think, are making contributions there. But I really think that it would help to conceptualize this whole topic of events, event sequences, and the different roles they can play a little bit more in order to create better synergies, not just within the community, but also with neighboring communities. So having now talked a little bit about the notion of events and event sequences, the next part I would like to talk about is that we are usually not stopping there, right? Once we are observing relevant events that are relevant state changes, we can also build systems that are reacting to them, so-called event-driven systems. And what I find quite interesting also in that context, that there is quite a confusion and quite different understandings of what event-driven architectures are, or event-driven systems are. And I can just recommend this very nice presentation by Martin Fowler on the many meanings of event-driven architectures that explains very nicely the different functions events can play in an event-driven architecture. The most basic one is that events are seen as a notification mechanism. So a relevant state change happens within my service, and I'm emitting an event to inform everyone else that something relevant has happened. In contrast of using commands, what happens here is that we are having a dependency inversion, and that we can create very easily decoupled systems, because we can very easily add additional consumer components that are listening to those events and are reacting to them. What you can, however, also do using events is state propagation. So in this case, events would be a little bit richer and contain enough information that we can transfer the state from one system to the other. This is, for example, used within microservices to keep, for example, replicated databases. And I think what is especially interesting for many of us is events as a source of truth. So in the software engineering domain, this is often referred to as event sourcing. And this goes clearly beyond just having an audit log or an event log. But event sourcing is really about building systems where the entire state changes, the entire changes to the system are based on domain events. If we do that, and domain events are really the driver of change, and have this source of truth, then we can do all sorts of interesting things. We can do time travel, go back in history. We can also make a snapshot of our system and use alternative events, scenarios, in order to make what-if analysis and simulation, or we can use that to create a memory image. And I think it's quite related to some of the things we try to do with the notion of a digital twin. So again, I was looking a little bit at the different papers that have been published at CAiSE in the previous editions, and 13 of them took, I would say, a strong systems perspective. So the system was not just a remote aspect, but was really in the center of the paper, either from a requirements perspective, more from an architecture perspective, or a couple of model-driven approaches have been proposed where events played a central role. So what I found is a few papers on event production, so a TSL for event modeling. Also a couple of papers really used event notification to emit relevant events. Few papers, again, the data perspective is not so well covered. Data ingestion and integration only taken up by 2 papers. What most papers focused on is the detection of events, either just by monitoring or by using one or the other form of event processing to move from low-level raw events to something which is meaningful to react to. And in one case, there was also a component for event prediction. What also most of the papers that took a system perspective covered is the handling of events. So if you find something interesting to react to handle that. Most of the papers still took a reactive approach, so to just react to events, while there is also a few approaches that take a more predictive lens and try to predictively handle events. And I could find one paper that is is talking about analyzing the impact of an event that has been observed before doing some replanning or rescheduling. So you can see that also from a systems perspective, there is quite a lot of work that has already been done at this community. Before moving now to my own research, I would now like to point out an additional role events can play, and this is the role of events in the context of process science. So we can use events to study continuous change. And several of you might remember the keynote of Jan van Brocke, PPM 2020, where he talked about process science. And again, this is not just about business processes, this is about a much wider notion of a process where we have data organized as a coherent series of changes that unfold over time. Translated to my presentation, we essentially have digital traces and that are and underlying some sequences of events, which we can exploit to analyze how certain phenomena evolve over time. After the keynote, there was also a brief paper published about this whole idea of process science, dividing process science activities into 3 different phases. On the one hand, we have discovery, which is about representing processes using digital event data, event-driven architectures for collecting data. And this is, again, an aspect I have not seen addressed very much at CAiSE so far. And of course, different approaches to identify pattern at that level. And I would say a big part of what we have done as a community in the last couple of years is related to this discovery stage. The second phase is about explanation, so to understand why and how certain processes unfold, so to understand the context in which patterns are situated, and also to look into cause-effect relationships. Looking at this year's CAiSE, but also maybe the last 2 years, there is now an increasing attention to move from discovery more towards explanation, to look into cause-effect relationships, to use simulation to better understand the context under which certain patterns happen. And why are we doing all of that? Because in the end, I mean, we want to use all of that in order to intervene, in order to make interventions that are leading to some improvements or reactions in the real world. And the third part is about developing and evaluating interventions and to build systems. I think what is also interesting when you look at that slide, that the different, I was yesterday at the TC, that the different research, big research paradigms, the science and empirical research, more and more converge because you essentially need both of them in order to answer such questions. What I would now like to do in the remaining time is to briefly talk about some examples from my own research. And you will see that it is quite diverse, but event sequences play a role in any of those. The first example I'm going to talk about is about cognitive processes, and more specifically, what we do in that context is that we try to trace developers using physiological and behavioral measurements to explain difficulties those developers perceive in software to potentially then intervene in fault-prone situations. What we use in that context are sensors for collecting behavioral and physiological measurements, and you can just see a couple of examples. The concrete modalities I don't think matter for this keynote. I think what matters is that all of them produce event sequence data. And we are usually working not just with one event sequence, but with multimodal data. Having multimodal data makes things substantially more difficult because you need to think how to synchronize the data, and every one of you who has attended a distributed systems course knows that this is not trivial, and especially if you think about neurophysiological data, we have data that comes at a very low, high temporal resolution. So it is really important that the synchronization is precise, and it's something that already needs to be taken care of at the moment of data collection. What is an additional challenge with physiological signals is that there is, depending on the modality, a different latency between a stimulus representation and until you can see an effect of that in the signal. In past CAiSE conferences, there was so far one paper in the period I've looked at that looked at synchronization of events and data collection infrastructure to handle those aspects. Now let's assume that we have managed those challenges. Then what we can do is that we can look at event sequences unfolding over time, and we can try to relate the different event sequences. So for example, what we can do is that for one particular, in this fixation event, we can look at some other measurements that happened in close temporal vicinity, like pupil dilation, GSR recordings, and so on. Those of you that have done some classical eye tracking know that what is typically then done on the eye tracking side, so on the fixation side of things, is to group and aggregate fixation events, and they are typically organized in areas of interest. So the spatial dimension of an event is taken into account to create groups, and then to calculate measures for these particular groups. So this is state-of-the-art approaches to analyze eye tracking data where both the temporal and the spatial dimension are taken into account. This works very great for static stimuli, but the moment you want to research large systems, systems where you have scrolling and zooming, systems where you want to investigate real software systems that are not just a mini source code snippet, but where you have large systems with many files, this manual creation of areas of interest is not feasible. But what you need to achieve is to really link the two data sources, so our event sequences with the artifact at hand. So what we did to overcome that challenge is that we tried to map really the fixation event to the artifact and to already at the moment of data collection, enrich our event sequences. So to enrich each fixation event with information about the artifact. This doesn't come for free, but really requires an entire data collection infrastructure to take care of that. So the idea here is to really enrich fixations with artifact information during data collection. And what I mean with artifact information is information, for example, about the source code element to which this fixation belongs. As already mentioned, this enrichment shouldn't be an afterthought or even cannot be an afterthought, but already needs to be taken care of at the moment of data collection. And that's why I think we should pay as a community much more attention, not just to the analysis of data, but also to, how to get interesting data, potentially also multimodal data we can analyze. In the context of software, there's a plugin developed at the University of Toronto, CAiSE'22, that is taking care of that, which we used. And for process models, and I would say conceptual models more generally, postdoc of mine is currently a plugin that allows to do such experiments or data collections where fixation events can be mapped to the artifact. So having done that, there are now two main benefits. On the one hand, we can use this enriched data to dynamically create AOIs. And not just stupid AOIs, but we can exploit the whole structure of the artifact, syntax and semantics, to create sort of semantic AOIs. So we could automatically create AIs for each block of the source code, or we could exploit, when we talk about source code, the abstract syntax tree. When I talk about process models, the process structure tree, in order to, for example, create AI, label our data, for example, according to different control flow constructs, different parts of the abstract syntax tree. All of that dynamically. What we can additionally do, and I think this is also something which is interesting and which often comes either by relating an event sequence with, in this case, it's an artifact, or to combine different modalities, is the contextualization of events. So what we can additionally do by leveraging this mapping is to contextualize fixation events. So we know for each fixation, the source code element, we can infer to which source code block it belongs. So we can also contextualize the event with all sorts of artifact metrics, artifact features that are characterizing our event. And of course, since we have this temporal relationship between events, we can also contextualize fixation events with, for example, behavioral or physiological features that are happening in close vicinity. This is something which is now, of course, pretty much eye tracking specific, but I would love to see a little bit more of, I would say, enriching event sequences with additional data sources, taking multiple data sources into account, because I think there is not just a big potential for the specific research we are doing, but I would say for event sequence analysis in a much more broader sense. Before I now go to the next example, I just would like to briefly give you an appetizer of the iMind plugin Amin is currently developing, which we want to try out in a large-scale eye tracking study. But in case someone is interested and has ideas, we are super interested to collaborate on that. So what we can essentially do immediately after data collection to create this dynamic AOIs, and then to project all sorts of interesting metrics onto the artifact. So in this case, you can see one of the gateways with projected information about all sorts of metrics, eye tracking related metrics, metrics related to the pupil size. And we can also do that, of course, for entire blocks like sub-processes. Contextualized fixations do not only offer, I would say, opportunities for entirely new, I would say even entirely new classes of experiments that can be done, but it can also be used for fine-grained analysis of cognitive load. So we can use our event sequences that we have collected, extract features, and then use them to do not only make statements about whether the source code is now difficult or not, but to really pinpoint where in the source code different difficulties are. And now imagine that this works online, and we have all the information about the artifact, metrics, physiological metrics associated. This then also can really help to develop very concrete and tangible interventions. Of course, we are not there, but I think at least the infrastructure is there to look into these type of aspects. And now, imagine we have a very nice classifier, fine-grained cognitive load that is now raising some flags. Then this can be part of a so-called neuroadaptive software system that that collects sensor data, does some processing in order to detect relevant events to detect for, could be in our case cognitive load, and then to intervene or adapt the system in one way or the other. And in that context, event-driven architectures are a very good fit, but that alone is not enough. I think there are two very key questions to answer. One of them is how to intervene, and for that we need to really understand the context of the event, to be able to make assumptions about why it has happened. But there is a second interesting question is about the when to intervene. And whether to intervene immediately or to wait a little bit. And there has been also 2019, I see Klaus sitting here, paper by his team on looking into whether to, how long to wait in order, for example, to make a prediction. And I think this is a super important question, also in the context of neuroadaptive software systems, because you don't want with your intervention to create more mess, but you really need to wait for the right moment. And there are a few other people in the community that are looking into those type of aspects. And I think when we want to bring our concepts into real systems, I think those are super important questions to look into. And the contextualization, as I mentioned also, is also really key, because without the contextualization, we would know that there is now high cognitive load, but we wouldn't know why and where. Why I think it is really important to look into this contextualization more and more, and to exploit, I would say, more data sources going beyond, I would say, very basic event sequences. So this is the first use case I wanted to talk about. Now I'm bringing you to a totally different use case. It's a use case on the process mining. Francesca and Lisa from my team are sitting here that are working there, and we are also working together with Nina on this topic and related questions. And here the question is really to obtain a comprehensive understanding of the process mining. So how analysts are conducting process analysis. What we do in that context is that we collect interaction data, but also interview data in order to elicit frequent pattern of effective and non-effective behavior. We look into analysis profiles, common strategies, typical challenges. And this is the stage we are at the moment in the project. But the long-term goal and vision is to create methodological guidance and operational support to assist novice analysts. Those of you that have attended BPMDS, Lisa was presenting their paper on challenges that are happening during process mining projects. And this work has also confirmed that there is really a need to support analysts. Like in the project before, we are relying on multimodal data, so not just one single perspective, but we are taking several perspectives in. And in this case, we have interaction data that are coming in two different flavors. On the one hand, we have screen recordings, and on the other hand, for those tools that provide it, we have low-level application logs. And we have verbal data originating from transcripts. Of course, also here the challenge is to bring all the data together to synchronize events along the time axis. But another challenge we had in the context of this project is that event logs really come at different abstraction levels, which also had to be consolidated before starting our research. The next step, starting from that raw data, was then the creation of user behavior logs. And this is really the most challenging step. So the most challenging step is not the analysis and the application of the algorithms, but it is the question, what are events indicating relevant state changes that should be put into an event sequence? So the generation of the event sequence that we can look at things from a process-oriented lens, this is really the challenge here. Because the challenge is that the relevance depends on the purpose and is to a big extent determined by the research question, the analysis question. And there can be low-level questions, like still quite descriptive questions. How was the evolution of tool usage over time? How did artifact usage evolve over time? There are still questions relatively close to the tool and not yet that interesting. Other questions, which I think are already a little bit more related to what the analyst really does, would be questions, how are questions developed during process mining projects? Or what are common strategies analysts use for verifying, for example, artifacts or findings. So depending on the question, there are many different dimensions you can look at. So you can look at things from multiple perspectives and also at different abstraction levels. And to figure that out so that you afterwards find interesting aspects, I think is the most challenging part of this type of research. And I'm now illustrating you just for one simple question, this evolution of tool functionality over time, how such an interaction or behavior log could look like. So in this case, we would have an event sequence derived from the interaction data, which is showing the tool usage over time. And we could just capture that as an event sequence, where each of the, whenever the user has moved from one tool functionality to the other, we could annotate the data set with timestamps and then obtain an event sequence, which is showing the tool usage over time. Of course, this is nice, but not yet very helpful, because most of the time what you lack if you just have the interaction data is the possibility to really interpret the data and to understand what it now really means. And here, again, having multimodal data is really helping. In our case, we have interaction data plus the sync allowed data, which can sort of help us to contextualize what we see at the level of the interaction data. So also in this case, triangulation, looking at things from not just one event sequence, but to combining different data sources, I think it's really critical. Now I would like to show you, because looking at tool evolution, that's nice, but I think what we are typically interested is in questions that are closer to questions that an analyst would really care about, or that could also lead to some potential tool support guidelines for our target audience. So one of the things we did, and this is going to be presented at PPM, together with Francesca was driving the work, and Pnina was also involved. So we tried from the interview data, we derived common strategies that happen in the analysis stage. So what we obtained are 16 different strategies. The PPM paper is only about the interview data, but we are now in the process of combining things also with the interaction data, and I think this has really a lot of potential, because the tool, the event sequence I've shown you before, which was created based on tool usage, could now be linked to the strategies. And again, we can exploit the think aloud or interview data we have to make that match. So for example, one of the strategies was about verifying artifacts and findings. And what one of the users or interviewees was saying, that I'm often combining different tools for sanity check if we have the same insights in different tools. And this is, for example, now also a behavior which we can see in the interaction log. So as already mentioned, the really, really difficult part here is about the creation of the event sequences, and that's a hard task. Also, I mean, many of the process mining methodologies state that you should start with a question. The problem is when you look into things where you don't have theories yet, that it's not always super clear at the beginning what the concrete question is. So you use the analysis, you do exploration in order to gradually find out what interesting aspects are. Very similar what you do in process mining projects. If you are early stage adopter, you try to find out what you can analyze. And this is a process which is currently not very well supported. There are tons of visualizations, tons of analysis techniques out there. And it's not so difficult to use them when you know how your data looks like, when you can characterize your event sequences, when you know whether you need global pattern or local pattern, you want to look at one user or multiple users. But if you have not figured out yet what your event should be, it's not so easy to decide which technique to use. So what would be really nice is to find some better ways with the help of visualization to support this process of pattern discovery, better especially in situations where you don't have a clear understanding yet. What I would also like to point out that there is already super interesting work at that intersection. Also Jan, who is sitting here, was very recently doing very nice work, which is looking at the analysis of event sequences from two different perspectives, process mining and also what the visualization community has done. A community that also deals with event sequence data, so I can really recommend that. And I would also like to promote the upcoming Dachstuhl seminar. Pnina is here in the organizational lead, which will take place in about a year, to explore synergies between the different communities. Process mining, event sequence analysis on the one hand, and the visualization community who has looked at event sequence data also for, I think, a couple of decades. As a very last but very brief example, I would now like to dig into IoT-enabled processes coming from cyber-physical systems. This is the third application area we are working on, and in that context, we're working towards online conformance checking with ambiguities driven by the Internet of Things. I will keep that short because we are relatively at the beginning of this project. It was just recently funded with Luciano Banuelos Garcia, many of you know, involved, and we have a couple also of collaborators that are attending here. And the idea of that project is to use IoT sensors to discover process activities, and then to do some online conformance checking, taking care of ambiguities, which also links very nicely to the PhD work of Marco, who is sitting here in the room. We will look at it from two application areas, Industry 4.0 and healthcare. But I think what is interesting for this keynote, we have again event sequences, and not just one, but multiple, which we want to combine and make sense of. And in this case, we want to bridge abstraction levels from low-level sensor data to process event logs. So this is an area many people have looked at. And what you can see here on the right side, it's a very nice approach, which is especially, I would say, followed by the team of Stephanie at the Technical University of Munich. And I would say this would be the ideal approach if you can do it, to use the process engine to collect IoT data in context. So that's what we do in the eye tracking setting, and brings us already at data collection level a unified view onto processes and IoT events. In our setting, this is not possible because we want to monitor processes that are not driven by an execution engine. We have low-level IoT sensors, but still what we want to achieve is end-to-end visibility of the process. In this case, we now need to do the difficult task of moving from low-level data to something which is meaningful at a process perspective, with some extent of domain knowledge. So what we are thinking about is to at least exploit the topology of the cyber-physical system. So to combine, I would say, domain knowledge with the sensor data. It's also a topic, I think, which has still a lot of potential for research for this community, this intersection of event-driven and process-oriented systems. What you can see here are 2 articles emerging from 2 Dachstuhl seminars at the intersection of events and processes, or BPM and IoT. Many benefits were raised, many challenges, and many of those challenges are still open that provide very interesting challenges, I would say, for the IS engineering community. I'm running out of time, but I'm also already at the end and would like to conclude. So I hope that I could convince you that events are really everywhere. They can come in many different flavors and play an important role already at the CAiSE community. What I would also like to emphasize that it really pays off to carefully plan data collection and to spend more time on thinking how to collect nice data sets that we can work on, and not to just assume that things can be combined retrospectively. Because it's many times much harder to, from a low level, to come up to something meaningful than to emit meaningful domain events right away. And I would like to come back to something where Nina was citing me on the panel. We shouldn't pretend to be more stupid than we are. So when we know that something is meaningful and is also meaningful for others, why not emit that at the right abstraction level right away? We don't need to do discovery in all the cases. I think discovery is great if we cannot emit events at the right abstraction level, but I think we need to find a little bit of a better balance between, I would say, modeling and discovery again. What I think is also important to notice is that there is a huge potential for multimodal data, contextualization of events, something I would like to see much more at CAiSE conference in future editions. I think there is great research potential. But again, data collection is important for that because it can often not be done retrospectively. Another area where I think that modeling conceptualization isn't hurting is when we move towards explanation, because if we move towards explanation, then we have to deal with confounding factors. They are not always in the log, and I think it's important to think about conceptually what is there, what is missing, how can we ensure that more is captured, because otherwise we are making interventions that are not really based on, I would say, true causation. And finally, I think there is a lot of potential also for synergies with neighboring communities. I mentioned just a few examples already during my presentation. And I think a clearer conceptualization of events, event-driven, and so on could also help, event sequences could also help to foster such a, I would say, cross-disciplinary dialogue. So I would now, as a final thing, thank my team, also our collaborators, because research is never something which is done in isolation, but it is something which is a team effort. So I would also like to, to say thank you.
Questions? We have time for a few questions.
Well, thank you Thank you very much, Barbara. It has been a really great presentation. I think I understand how you were preparing it during the last days, because you are transmitting in a very convincing way a message that is clear, that is these different flavors of events. So I found your speech very clear, and I have two questions. I think that they are clear and they are generic also and are a consequence of the clear explanation. The first one is the ontological background. I am playing the round of Giancarlo and Renata, I guess, just asking about the need of having a precise definition of what is an event. Because as you are saying, there are many different flavors, and people many times are using or are discussing on events, and probably they don't have the same intuition in mind. The definition of event as a universally, widely accepted definition is not so clear. So the first question is well, if we need to have a kind of foundational ontology of events or a kind of precise definition of the event and all these different flavors, dimensions that you are mentioning, what would be the reference that we could use, or should we need to define one? And the second question that is related with the first one is the modeling perspective, because we are used to have clear tools for data modeling. So from the conceptual modeling point of view, if we ask everybody here what are your favorite data modeling selection, people would say entity relationship model, UML class diagrams, or whatever we want. But what about if we ask the question for the events? What are your event modeling favorite selection? What to use for modeling events? And how to combine the connection between data and events modeling? Because UML class diagram, for instance, have in the class construct, they have attributes and operations. Are operations events? Probably yes, but sorry? Yeah, sorry. Klaus. Well, I was just finishing. He yes. Knew that.
So Oscar, I think there are many questions in your one question. So I would say, yeah, I would definitely see a benefit of a clear conceptual understanding of what events are. I think within the subcommunities, to some extent, this has happened. But when you then look across communities, my impression is that it's still quite confusing. Also, when it comes to events, I mean, modeling techniques, I think, so what I'm aware of in the context of domain-driven design, that a couple of techniques have evolved around event storming in order to think about systems by putting events very much into the core. But my impression is that this is not yet very widely adopted. And I especially haven't seen in our community picking up those concepts. I think in the software engineering community, with the advent of microservices, domain-driven design, which goes already back many years, has I would say received some new attention. But I haven't seen those things being picked up at our end. What I would you asked about also this balance about modeling and, I mean, coming up, discovering events, low-level events, how to combine that. I think that this is from a conceptual point of perspective. I think this is not that difficult to achieve. So on the one hand, I could, when I'm now thinking about domain-driven microservices, I could already emit relevant domain events someone else can react upon, and it is then on the consumer side to decide whether it's worthwhile to react, right? And I would put those pre-modeled events onto an event stream or into my messaging system, and someone else is reacting upon it. At the same time, I can use data streams or complex event processing where I'm ingesting low-level sensor data, where I'm, for example, do some either low-level pattern on time windows, and I'm reacting if a certain threshold is exceeded by putting this detected event onto another event stream which I'm using to reacting. So I think on a technical level that can be very easily combined. I think what what I think but what I think would be very helpful, especially, for example, this whole annotation we had in our process mining research. That would be so much easier if the tool vendors would already emit reasonable events so that I don't need to reconstruct everything afterwards. So I think there could be a lot of stuff that could be done at the level of the API design. I think Klaus probably knows more in the context of cyber-physical systems. There are more and more services emerging that are then also emitting interesting information about machine states and so on. And I think this would make our life much more easier if the producing component is already emitting interesting stuff.
In computer science, we love that anything is digitalized, and any world is digital. However, other scientists don't believe in our digitalization. Think about heart research. There are about 800 human heart models, and I think not more than 50 of them are digital models that can be handled by our data-driven approach. So how to handle now analog events?
So I think this is, so when you remember the first slide I showed, if you're able to detect a situation in our IT system, then we can make a record of it. And I think the problem is with things that are outside, we won't be able to capture them in the system unless someone is putting them into. We either make it observable, so for example, by using, I don't know, computer vision to observe certain events to make a record of it, or I think they are outside of what we can analyze in our event sequence data.
This is the end. Thank you very much for the interesting talk. Questions.